Oo.
So once again, good morning.
Sir.
So can you guys see my screen now?
Ah,
Is my screen visible now? Hello?
sir, kita sir. Naka-on pa lang.
Okay. All right. So before we proceed to week 5 and 6, so does anyone has a question so far from week 1 to 4?
Sir, wala naman sir so far.
Ano,
So
sir?
everything's good up to this point. Okay, so here's the thing. As early as of now, I would like to tell this one. It seems like the lecture and then the laboratory subject of Ma'am Suarez, I think she's the one who've handled this one before, and then this is the one that this is her uh module that I'm using right now. So this one came from her. So it's like a mixed lecture and laboratory because I saw that the module 3A is actually your module 2, your second module, okay, in your laboratory, okay, which is assembly language programming structure, where in module 3 here is assembly language programming fundamentals. So both of them have different, a little bit of different titles, but not this one. Structure nga pala, not fundamentals. That is why. Bakit magkaiba sabi ko? May parehas naman. See? Okay, so this is the module 3, 3A that came from lecture. So it's a little bit different from the start because we have an additional, like what is ISA, what is assembly language, and then we have this demo right here. But starting from slide 4, okay, this one right here, is now your module 2 in laboratory, okay, which is the assembly language programming structure, which is the classes of statements. And yeah, it's already the classes of statements, instructions, directives, operations, and everything now is the same up to the last slide. So you guys will see here that we have task 3.1, okay, under module 3A, but this is actually your module. I love number 1, okay, and I did check one, everything one by one. Number 1 is the same with your number 1 in a laboratory, okay, so we have the same 1 to 5, and then we have the same letter B, which is also 1 to 5, and then we have the same letter C, which is only one number. Okay, so that is why we will only discuss, and I'm pretty sure that all of you has a laboratory, right?
Sir, ako po wala sir.
Okay, don't worry.
Sir, wala din po ako.
So, wala
Yeah.
dito sir.
Anyway, so I made I do know one who doesn't have a laboratory. That's Mr. Gapo, since that's his ECE. This is just a replacement for his subject. So that is why I have already uploaded the pre-made video. Okay, so this is the part where I've discussed the entire module 2 in the laboratory. So just check this one out. So this is a 43-minute video. So this one discusses the slide 4 of the module 3A. Slide 4 up to the last one. Okay. So I would like you guys to watch this one later on once we're done with our meeting. So I will do this one so we can save time, okay, because it took us 2 meetings, I guess. I just cut, okay, the others that is unnecessary, of course. And yeah, that is why you guys are only seeing 43-minute video, but in both that, I think this is an hour, more than an hour. Okay. So are you guys okay with that? because we still have another module. We're actually going to discuss two module for today's meeting, which is module 3B. So are you guys okay with that setup?
Yes, sir.
Yes, sir.
Anyway, we'll be, go back to 3A from time to time if it's needed, but while discussing the 3B. But yeah, anyway, so let's start now with the 3A. So module 3A is the about instruction set. So this module will introduce the instruction set of a basic microprocessor using assembly language. So it consists of practice activity and how to create instructions for a microprocessor. So in this module, you will explore one of the most known microprocessors, which is a times 86 architecture. Okay. So the first major topic is the assembly language fundamentals, which is the one that we're going to discuss for today. And then the second major topic, which is the assembly language instruction, will be discussed under this pre-made video. So we will not discuss this part anymore because it's already discussed on this pre-made video. Okay. So here are the learning objectives. The first one is to understand what is instruction set architecture in computer processing. Second is to identify the structure of times 86 microprocessor. And then the last one is to develop basic assembly program or instruction for 86 microprocessor. Okay, so here are just the basics, or what is ISA, or what is this instruction set architecture. So ISA defines the set of basic operations computer must support. Okay, so we actually have a lot of different structures, different architecture. Okay, so times 86 is one structure or architecture. We also have 8051. What else? So we do have a lot of different architectures, but all of them are assembly language, but they have their own ways of constructing their codes or program. Okay, so an ISA is independent from microarchitecture, which refers to the implementation of an ISA in a processor. So a single ISA can have different microarchitecture implementations. So typically, an ISA will include instructions for data handling and memory operations, arithmetic and logic operations, control flow operations, and co-processor instructions. So basically, when we see instructions, those are the verticals one, the program itself or the code itself on how that a specific microprocessor works. So it could be arithmetic, logic operations, how to control the flow of operations with the loopings, or co-processor instructions. Okay, so an ISA also defines the maximum bit length for all instructions as well as how an instruction is encoded. So having a definition of an ISA allows hardware and software development to be separated from each other. So this allows the company to develop hardware while multiple other companies can develop software, knowing it will run on that hardware. So basically, it's like a standard way or standard architecture for all of the hardware that is being created by different companies. So they already know that this will work, okay, because they're using the same architecture. Okay, so that's it for the ISA. And then assembly language programming. So the first thing that you guys will know about assembly language programming is this is a low level programming. Okay, so we could see that low level programming is really, really hard to understand, and then really, really difficult to execute, since instead of having one line or two lines of codes, let's say in Python versus Python, okay, it's a super high level language. So in assembly, you need like maybe 10 lines, okay, or more just to execute a hello world. Okay, while in Python, you only need one or two lines of codes just to execute or to print a hello world. Okay, so that's the main difference between low level and high level programming language. Okay, so this may be produced by compiling source code from a high-level programming language such as C or C++, but can also be written from scratch, of course. So assembly code can be converted to machine code using an assembler. Okay, so in here, we have a lot of process, like you have to create that one from scratch, and then you need to compile it and then assemble it before, or you can sometimes you even need to convert that into a machine code. So we have a lot of processing just to make this one work into a certain let's say certain things. Let's say certain process or certain microprocessor. Unlike in a high level programming language, it's very compiled as one. Okay, so just compile it, check if there's an error, then once it's already done, then it's already working as it is. Okay, so in order to create assembly language program for a microprocessor, programmer must be knowledgeable with structure of the microprocessor. So this includes different components of the microprocessor. A typical microprocessor has three main components. First one is the registers, second is arithmetic logic unit, and then the last one is control unit. Okay. And then assembly programming focuses on registers. So these are small size memory unit inside the microprocessor. So an extremely fast memory unit used to create and store the results of CPU operations and other calculations. So there are different types of registers with different sizes and different functions. So knowing this would allow programmer to use the right register for the given instruction and data. So in this lesson, times 86 microprocessor is used, an example and basic of the ISA. So each register was described in module 1. Okay, so you can guys go back to module 1 on what are those registers. Okay, so just like a recall on what are those registers. So again, we only have 4 basic registers or the data registers. So the others are pointer and then index registers, but mostly this is the one that we are going to use, the EX, BX, CX, and then DX. And then the others are also, of course, registers, but we are a pointer register and then an index register. Okay, so we also have a small segment register, like, of course, we have the EH, and then EL, BH, BL, CX, CH, CL, and then BH, DL. We also have this one, okay? So they are also a part of smaller segment, okay? So we have CS, DS, SS, ES, and then IP. Okay, so you guys can also use those for small size, let's say, storage. Okay, so in most cases, maybe this one is 8-bit, 8-bit. Okay, that's the maximum storage that they can, or address that they can store. Okay, and then this is how it works. So it goes internal bus, temporary register, ALU, and then some flag. So we'll not discuss this one anymore. So what's important is the register. Okay, so again, we have this one for the registers. We only have EX, BX, CX, and then DX, and then their corresponding smaller segments, which is 8-bit, 8-bit. Okay, so the entirety of this one, let's see, each row, for the EAX, that's 32-bit as a whole. Okay, if you're going to use, let's say, EAX, we already know that the size of that one is 32-bit. For the AX, that's only 16-bit. Okay, and then we have smaller segment, which is 8-bit, 8-bit, which is the AH and then AL. Okay, so I hope we are clear with this one, and it's very straightforward, I guess. AX is 32-bit, AX is 16-bit, AH is 8-bit, and then AL is another 8-bit. Okay, so similar with the EBX, BX, BHBL, and so on and so forth. So you can use any of those registers. You can store, you can use to transfer data, register to register, register to, let's see, memory, or memory to register, or let's see, direct data to register. Okay, it just varies with the sizes, okay, that they can carry or they can store. Okay, so let me ask someone, Mr. Martinez, what is the size of the X?
32 bits, sir.
Ilan?
X, sir, 32 bits.
The X? Are you sure it's 32-bit for DX? As in D and X only, this one. What about Mr. Polmano? What is the size of BL?
16 bits, sir.
BL.
BL. 8 bits, sir. 8 bit.
Okay, so everything that is under here is 8-bit, 8-bit, 16-bit, and then if it's the entirety, let's say EAX or EBX or ECX or EDX, they are all 32-bit. Okay, and this is just one example of an architecture of a let's say bit times 86. And what is the highest bit that we can use right now in our computer? Isn't it that it's already 64-bit?
64-bit.
64-bit. So that is why this one is, to be honest, maybe this is not being used nowadays. Okay, so maybe some companies still using 32-bit microprocessors, but of course, 32-bit is a lot slower than 64-bit. So 64-bit can handle more data, of course. It can process a lot of more data in one processing or in one clock process. So this is just a reminder that in times 86, it's up to 32-bit only. Maybe in some architecture, maybe a more a higher microprocessor or more latest microprocessor, it's now up to 64-bit. Okay. All right. So slide 4 to up to the last, including your activity. Where is that one? This task 3.1. Yes.
Oh, tago mo. Sige yan. Kabalbon.
All right. Okay. So including the task 3.1 under module 3A, okay, which is this one, this 3.1, is already discussed and previous. So I would like you guys to watch this one video once we done with our meeting. Okay. Just a brief discussion on what are things that we discussed under this slide 4 up to the last slide. So basically, we have discussed here the instruction, directives, and then pseudo operations. So we have we have only focus on directives and then pseudo operations. Instructions are the symbolic form, which is this one, that model, that's that data, even this DB or that code, and right here. So where you guys need to focus is the directives. So everything that is under that data right here is our directives. So when I say directives, these are our initialization. So this is where we, let's say, declare a variable, in other words, but in assembly language, we call that one directives. Okay, this is where we declare a variable. Okay, and under that code, so in here, everything you will see here is, of course, the pseudo operations. So it could be a block and segment definition, a base register assignment, could be data alignment, okay, or an algorithm, okay, or the flow of the program, etc., etc. Okay, so everything here is how you will handle, let's say, your data, or how you will execute your program. Okay, and then end is, of course, a necessary thing. Just always put end. And then we have some fixed statements here, or a code. So that model small is a fixed one. So you guys don't need to change this one all throughout on this course. That stack 100H is already a fixed code. So you guys also don't need to change this one. So basically, you guys don't need to worry about that model and then that stack. The only thing that you guys need to worry about is the that data and then the that code. That's it. Those two only. And then the rest, they are already the same, including the end. So you guys don't need to change this one anymore. That's already it to end the entire statement of the program. Okay. So yeah, and then we have also discussed on how to define a variable, or how to initialize rather, in assembly. Okay, so of course they come with sizes. We have byte, we have word, we have double word, we have quad word, and then DP, which is also quad word, but this one can store a higher data. Okay, so this one is, let's say, 8-bit only. This one is 16-bit. This one is 32, 64, and then 80. So depending on the size of what you are initializing, so you can use different called this one pseudo operation or a code or function code. Okay, could be DQ, DD, DW, or DB. So depending on the size. Okay, so of course you cannot store. You cannot just simply use, let's say, DB if you have let's say small, let's say larger, but it's possible, but it will be sliced into a byte size only. Okay, so for example, if you will declare a byte, but it's containing a double word size, so this will be divided into two. Okay, so it's 45, which is 1 byte, and then another 60 for another 1 byte. So that's what's happening if you're going to declare it at 1 byte. So this DB, DW, and then DD will be the one that will be followed upon initializing those values. Okay. And what else? We have also discussed what is an offset, like it's the distance. Okay, like you're not sure where that data will uh or what is the exact content of that data. So you can use offset. Okay, if you know the distance from this point to that point, you can get the registers after, or let's say within. Okay, so you can use offset. Anyway, it was discussed under here. Let's check this one out. And then we have also discussed the data item attributes. So this is a very straightforward example. So we have the type, which is this one could be DW, DB, or let's say DB or DP. So if it's a byte, it's type 1. If it's word, it's type 2. If it's double word, it's type 3. If it's quad word, it's type 4. If it's BP, which is also quad word, it's type 5. Okay. So for the length, this is the length of this one, the characters. So we have 250, and then in here we have 3. Okay. So 50 is different from 35H. If it's ending with H, this one only means that this one is in hexadecimal form. 50 is a decimal. Let's say we're saying we have 50 different characters in here. And here we have 200 different characters in here. Okay, and then for the duplicates, this will be a long explanation, but duplicates like from the word itself, duplicate, it duplicates 200. That is why we have 400 in here. And then duplicate 0, duplicate nothing. Okay, so that is why it still stick with the size of 50. Okay, and then here we have a size of 3. So this is the first one, second one, and then the third one for the DB. And then here is like a summary of what is that model, that code, that stack, that data. Okay, so again, for the that model and then that stack, we are a fixed value for this entire course. So for the that model, just use small. Okay, so no need to use tiny, no need to use medium, no need to use compact, large, or huge. Well, that already depends once you are already on, let's see, on the field. Of course, it's already a larger let's see, program, or a larger functionalities or processing. So maybe you can use a medium, or let's say large, okay, if it's a multiple segments, or huge if if it really exceeds the array to 64K. So depending on what you guys will believe. But for this course, small is already enough. Okay, since our program in this subject is not that too long. Okay, so just to be safe, just use small. Actually, tiny is already also enough, but just to be safe, small will be the one that will be used in this course. Okay, and then the next one is already your 3.1 task, which is also discussed and used a previous video. Okay. Anyway, so that's it for the module 3A. So does anyone has the question or clarification so far?
Answer.
Okay. So again, for this slide, for up to the last slide, please watch this 43-minute video. So this is what that one was discussed under Micropro laboratory. Okay. So let's now move on to the next one since we still have another module to discuss, which is the data movement or the transfer instruction. All right. So for the assembly language programming, here we now have the instruction, which is the how do we construct a line by line code. So basically it contains these parts, this label, this mnemonic, operands, and then a comment. So we can have up to 4 parts, but in reality we can only use 2. Okay, or we're only going to use 2, which is the mnemonic and then the operands, because label and comment is just an optional thing. Okay, label is used for you to easily navigate or easily jump to that specific line if you're already using, let's say, a looping statement. And then comment is just, of course, a comment to say that maybe this line is for etc etc. So that depends on what you're going to put on that comment. Okay, basically what's important is the mnemonic and then the operands. Okay, and then we also have types. So the data movement or transfer instructions. We also have basic arithmetic instruction and then the sequence instruction and then the interrupt key or the in instruction. So discussion of this type within the discussion of the other type. So it will be discussed along with this discussion on what is this interrupt. So before that, let's proceed to data movement first. So the first thing that you guys need to know in assembly is the word move. Okay, I think it's also super obvious. Okay, it's just it doesn't have an E, but it moves data. Okay, this is used to move data among the different units of the machine. So it's a move instruction. So you can use small letter MOV or a capital letter MOV. So in assembly language, it's not because one key sensitive. Okay, so either of those will be fine. Again, we have here the label, and then here is the mnemonic key or the keyword or the format, and then we have here the destination and then the source. So this is the operands. So okay, so here is the destination and then here is the source. That is one thing that you guys need to remember. Okay, so where will it go and then where it is coming from. So it's like from right going to left or going to the middle. Okay, so we have some examples here: register to register, register to segment register. We have register to memory. It could be direct or indirect. We have immediate to register, immediate to memory, or it could be direct again or indirect. Okay, so of course, register to register. Let's just go back to your 3A real quick. So again, we have 4 major registers, which is the EAX, EBX, ECX, and then EPX. And then we have segment registers. We have the AX, BX, EX, EX, which is just a smaller size of those. And then we have another smaller size of this A, B, C, and D. We have the H, AH, everything is H, and then we have the L, and everything is EL, BL, CL, and then DL. So that's the pattern that you guys, you know, you guys can follow regarding with this smaller segment, also one segment register. Okay, you can also use this one, but to avoid confusion, just memorize this one for now. If these variables is not enough, maybe you need more variables, then that's the only time that you can use the CS, DS, SS, and then ES, and then ID. For now, just be familiar with this one, since we already know that BH is 8-bit, BX is 16-bit, or EBX is 32-bit. So with that, we already know that the size of this one is something like that. And like here, we're not really sure, you know, how small size this memory is. So you haven't confirmed if CS is only 8-bit or 16 bits. It could be 8 or 16-bit. Okay. Well, anyway, so going back here, we have register to register. So what's happening here is whatever is the content of this ECX right here. Go back, zoom. Okay, so whatever is the content of ECX will go to EDX. So if you guys are going to take a look on the register, ECX will go to the EDX. Whatever is the content of the EDX will go to our EDX. So are you guys getting the idea? Are we clear so far regarding with this one?
Yes, sir.
Yes, sir.
Similar with the others. Everything is from right going to the middle or going to the left side. So EX going to ES. So ES is small segment register. It is under right here. And we have a direct memory going to register from DH to byte field, BX to DL. Okay, so this is the let's see, a function keyword for a memory. Okay, this is a memory. Sorry, this is the register rather. Register to memory. I'm sorry, this is the memory itself. Okay, and then this is a register. So DH. So DH came from here, and then byte field is, I don't know, but it's the memory, and it's the direct memory, so it's the byte field. Anyway, we'll not be using byte field for now, so I'm not really sure where we can use this one. But in this module, there were no example on how to use a byte field. So maybe Ma'am Suarez only focus from register to register and then registered segment. And we also have immediate, but for the memory, so Ma'am Suarez wasn't able to use this one, or wasn't able to give an example. Okay, but yeah, we can also do this one from register to memory, and then we have from memory. My apologies, mabaliktad ko na rin tuloy. From register also, okay, which is a BX going to the memory, but it's indirect, which is now EDL. Okay, and then we have immediate. When we say immediate, so it is not a register, it is not a memory. Okay, so it's a variable, okay, or a constant. I'm sorry, it's not a variable also. Okay, so it is a constant value. Okay, so it could be hexadecimal, or it could be a decimal only, or it could be a character. Okay, so in here it's a 40H, so it's a hexadecimal going to a memory or to a register. All right. Okay, so 40H going to CX, 25 going to byte field, and then 16H going to word field DX. Okay, so again, these are registers, small segment register. We also have this memory, which is the byte field. And when we say immediate, those are just hexadecimal characters or decimal characters, or just a simple character. Let's say 25. It could be integer or decimal. Okay. So are we clear so far regarding with this one?
Sir.
Okay, so
Yes, sir.
thank you. So we don't have enough time anymore, so we'll just continue this one on the part 2. So goodbye for now, and then see you guys later.
Bye, sir.
Goodbye.